So sine, an eighth power of sine, third power of cosine. If I have to split one of them, which one should I worry about? The sine part or the cosine part? The sine. Why? Hold on. The sine. Did you say sine or cosine? Huh? You changing your mind? Is it the sine or the cosine? Oh, cosine. Okay. The cosine part. Why the cosine change? It is odd, and our objective is to get to the sine part of the identity, or even part of the sine squared, even part of the cosine identity, cosine squared. So I want an even power for both. So I've got to split the cosine. Now I'm getting closer to the identity, sine squared x plus cosine squared equals 1. And whichever term you split, the opposite of that must be your u. So in this case, u would be sine x. Yes. Du over dx will be cosine x dx. Remember, du over dx is cosine x. You'll get cosine x dx. So, u raised a sine raised to the 8th power of x. Cosine squared, we want to write it in terms of sine. This is where the identity comes into play. I don't want to skip a step, which is why I'm writing this. Du. I can now replace sine squared x in terms of u. U is sine. So u raised 8 times 1 minus u squared, followed by du. Good. I can distribute u raised 8. U raised 8 minus u raised 10 times du. What is the integral of u raised 8? What? What? How do I keep hearing 9, but 9 what?
U raised 9.
9 inch tail? Never mind, it's a bad joke. Moving on. You know the band 9 inch tail? Don't? Okay. Okay, I think my age just came out of there. Let's ignore that. U raised 8. What is it?
I just won't answer anymore.
Okay, u raised 9 over 9. And what about the integral of u raised 10?
Oh my gosh. U raised 11 over 11.
Thank you. U raised 11 over 11. And we just have to plug in u back. So sine raised 9x over 9. Sine raised 11x over 11 plus. You may think, oh, things like that don't happen in life. You're wrong. Sines, cosines, very important. Differential equations you will see these a lot. Real life in general. Everything goes around that unit circle. You can't set that enough. Do we follow it? But pretty straightforward, right? If you pairwise substitution, a trigonometric integral in terms of sines and cosines, it's very straightforward. Good? Yes, no, maybe, Tony. Here is an example for you to try in our race. we'll do that. Give it a try. Okay, many of you are getting it, but a few things to know. As I went around, the first mistake that I noticed is some of you split cosine. You don't split up an even power. The only reason why we are trying to get an even power is the Pythagorean identity, sine squared x plus cosine squared x equals 1. What power does sine have? That's an easy question. And is it an even power or odd power? Even. What power does cosine have? Even. So what we want is get to an even power. So if I rewrite it in terms of an even power, then I can directly go to this identity. That is the key, and that is the reason why we are splitting the odd power. Every odd number is one less or one more than an even number. Agreed? So I'm going to start here. I can rewrite the fifth power of sine, fourth power times sine x, right? Your substitution must be the opposite function of the one you split. Well, I split the sine, so my substitution would be cosine. If u is cosine, du is negative sine x dx. Back to this. Let me rewrite it this way. It is a negative, I believe, like the number 2. That is negative du. Do we agree? So I'm going to write this part as negative du. That part is easy. U raised 4. And that was the challenging part, or that is the part where we converted the odd power to even. I can write the fourth power of sine in terms of its second power, sine squared x squared. Good. Now, back to the identity. The Pythagorean identity states that sine squared x plus cosine squared x equals 1, which would mean sine squared x is 1 minus cosine squared x. This is the part where I saw some of you make mistakes. You already look at the square, and in your mind, somehow magically, that square went away. You know, training. You see a square, you immediately say, oh, I already have a square, so I don't have to square the cosine. That square belongs in here. You have to first rewrite sine squared, so square must be there with cosine. It is not just 1 minus cosine x squared. So, first step, whatever I wrote inside the square bracket, which is sine squared, now becomes 1 minus cosine squared x. Some of you forgot that too, don't forget. Times, you raise 4 times negative du. Now I can replace that as u squared. Agree? Pull that negative out. Good. At this step, many of you were successful in getting the integral, which is a good thing. And what did you use this? You got it right. Oh, what? Chain rule? What are you talking about? Foil. Right, so you foil, simplify, that is perfectly fine. But I'm not going to foil because I'm special. What is another way? Wait, but just that answer?
Well, you're pointing to one number and then
There
pointing
is
to the
another reason.
parentheses.
I gave you the first reason, which is foiling, this is
You
it.
told us to foil.
Another.
That's what
That's exactly what she said. Pay attention. Looks like you didn't pay attention to that entire rant of me asking you to pay close attention.
I did.
Listening.
Integration by parts.
Thank you. Integration by parts. Part 1, part 2. Okay. Now, I said integration by parts because I'm special. Well, that is not the reason. You might think I'm special, but the reason here is it is best to learn integration by parts. Reason being, what if that expression ended up being to the power of 60?
That's okay.
That's okay. You're going to foil 1 minus u squared raised 16. Really? Okay, if you do that, come to my office, I'll give you an hour and 15 minutes. If you get it right, I will add 10 points. You get one attempt without a single mistake. If
An
you
hour and
do-
15?
Yes, I'll give you 10 points.
What would I have to do? Can you repeat?
You have to do 1 minus u squared,
1 minus u squared
Just
raised to the
that?
power of 16.
Just that.
but you have to do it by
Without a single mistake. You make a mistake, it's minus 10.
even in like 1 it's minus 10 if you get it wrong.
Well,
That's my problem.
we're all men. So the point I'm trying to make is she is going to make a mistake. She is going to lose 10 points. It is going to happen because I love math, even I wouldn't pretend that. If you have a big power, then it is painful to foil. And it is easier for me to simply go to integration by parts. So the u part will be u raised 4, the v part 1 minus u squared squared. Yes? What is another way of doing this? U dv 1 minus u squared squared, u raised 4 off the 2. One of them's easier. Which one? That one, why?
U to the 4 will go to 0.
Huh?
Then u to the 4 will go to 0.
Okay, u raised 4 would go to 0. You're saying no.
I just feel like it's so hard to integrate the other part. It's easier to do the chain rule over and over again.
Did you hear what?
What's that chain rule 10 minutes ago?
Oh, yeah, you were wrong 10 minutes ago, you're wrong now. So we can't use, well, we can use this, but it is going to be harder, like Caitlin said. This part, integrating, is painful. You can't integrate without foiling, and all I'm doing is trying to avoid the foiling approach. But I can recursively apply chain rule until it becomes 0. First time I do it, I would have negative 2 times 1 minus u squared. Yes, times. Got the bro? So, okay. So negative 4u times 1 minus u squared. I guess I'll do a distribution now because otherwise I'd have to use product rules. Over here, I need to integrate u raised 5 over 5, differentiate, minus 4 plus 12 u squared, integrate, u raised 6 over 30, differentiate, 24u, integrate, u raised 7 over 420, differentiate, 24, integrate, 3,360. Good. Now, people who got the correct answer, is that the right approach? Wasn't that complicated?
Yeah.
The approach, people who got it right, did
Yeah.
you do that?
No.
No, what did you do?
I just spoiled it.
A simple boiling. So, when I started, I said, I'm going to do integration by parts because I'm special, right? Wanted to show you this because if you have a bigger power, such as 1 minus u squared raised 11, foiling, not a good idea. But in a problem like this, if you chose integration by parts, it will be painful to do because you have a whole lot of terms, but from the answers you have, the answer was very simple. How many terms did it have? 3. Yes?
Yeah.
Those are the correct answer. 3 terms. So you might wonder, wow, my answer had correct answer has 3 terms. It's got a whole lot of them. Is it even possible? It is. If you simplify that huge expression that you get, it will reduce to those 3 terms. But at the expense of 3 to 4 hours of your time. I wouldn't want to spend that time. I made my point. If that power is too large, integration by parts. Otherwise, why make it harder? U raised 4, 1 minus, if you FOIL, you'd have 1 plus u raised 4 minus 2u squared. Distribute, integrate, and you are done. Agreed? So you've got to pick and choose your battles. Integral of u raised 4 is u raised 5 over 5. U raised 4 times u raised 4. Some of you wrote it as u raised 16. It is not u raised 16. It is.
You raise 8.
It is u raised 8. Very good. Integral of u raised 8 is u raised 9 over 9. And last step, negative 2. U raised 4 times u raised 2 is u raised 6 minus 2 u raised 7 over 7. There is a negative outside. So distribute the negative, you get negative cosine raised 5x over 5, negative cosine raised 9x over 9, minus 2 cosine raised 7, x over 7, negative becomes positive. So that is my final answer. Plus 3, thank you. But me being OCD, either write it in increasing powers or decreasing powers. I'm going to rewrite it in increasing powers of cosine. It's good practice. And of course, plus 6. Are we clear? What's up? Good. Okay, so there is no cosine term, but the process or the idea is the same. My goal is get to that Pythagorean identity. Pythagorean identity has an even power, specifically 2. Somehow I need to write it in an even power. So first step, I'm going to split it off by pulling one side out. I end up with dot. Yes? Step number 2. Whatever term I split, the opposite of that must be your substitution. So if I split sine, the substitution is cosine. If I split cosine, the substitution is sine. So u will be cosine x, du negative sine x dx. Good. Integral sine raised 4x. I can rewrite this part as negative du. All I have to do is find a way to write this in terms of cosine. This is completely doable. That is why we rewrote it in an even power. Sine, fourth power of sine is sine squared x, square the whole thing. I know u has to be cosine. It hasn't showed up yet, but I also know sine squared is 1 minus cosine squared x. Pull that negative out, du. From that point onward, the process is sort of similar to the previous problem. One minus u squared, square again, don't forget that part. There is a minus outside and du. What approach should you use? Should you go with integration by parts, even though it is doable? Should you try it here? No, it's going to get painful. So I'll just FOIL 1 plus u raised 4 minus 2u squared du. Integral of 1 is u. U raised 4 will be u raised 5 over 5 minus 2 u cubed over 3. Distribute and I'll write it in increasing powers. So negative u plus 2u cubed over 3 minus u raised 5 over 5. The last step would be to plug in our substitution. Negative cosine x plus 2 cosine cubed x over 3 minus cosine raised fifth power of x over 5 plus 6. Good. So there will be no confusion in terms of the answer if you have an odd power, even power scenario. But if both of them are odd, that's where confusion comes. Because no confusion, you've got to be careful to know how to go from one answer to the other, because you can pick either sine or cosine as a substitution.